Hey guys, today we're going to talk about part 4, chapter 9, the square root property and completing the square. If you picked up the cool down warm-up from in class, I realized that there were some problems on there that wouldn't quite fit in with this topic, so I redid the warm-up. So go ahead and, if you've already picked up the cool down warm-up, you just need to print out the warm-up, okay? You don't need both of them, you just need to print out the warm-up. So keep that in mind as we go throughout this thing, alright? So today we're going to learn how to find the roots or the zeros of functions if they have a root, because sometimes they don't have a root. So first let's discuss why functions have roots. Well, to your knowledge, how many roots does each of these graphs have? Well, let's talk about what we have here. We've been talking about roots as places where the function equals 0. Okay, well that would be on the x-axis. So this one right here has two roots, one here and one here. Okay, here this one doesn't touch the x-axis, so this has 0 real roots. Okay, and this one has 1 root. And this one right here has 2 roots again. Okay, all right. Well, let's rewrite the equation in vertex form and graph it, and we're going to find the solutions or the roots or the x-intercepts. These are all the same thing. Roots, x-intercepts, okay, from this function. So I'm going to go ahead and do that. First, divide by a. So I'm going to divide everything by a. So that's f of x over 2 equals x squared plus 2x minus 3. Now move the c. So I'm going to add 3 to both sides. So that's f of x over 2 plus 3 equals, plus blank. Need to make sure I have that plus blank in there. Equals x squared plus 2x plus blank. Alright, now to complete the square, I divide the b term on this side by 2, and I square it. So that'll be 1. And I'm going to add 1 on both sides. Over here is a perfect square trinomial, and that's x plus 1 squared. Over here, I can go ahead and simplify. F of x over 2 plus 4. Now I have to subtract 4 from both sides. And that gives me f of x over 2 equals x plus 1 squared minus 4. And now I'm going to multiply both sides by 2. So that gives me f of x equals 2 times x plus 1 squared minus 8. And there's my vertex form. So I'm going to go ahead and use this form. My vertex is at -1, -8. So -1, -8 is right. Let's see. 2, 4, 6, 8 is right here. On your paper, it's probably going to hit right at the bottom line. Okay. Then I'm going to draw the axis of symmetry right down here. All right. Okay, now I need a y-intercept. Well, I could look back up here and see what my y-intercept was. It was -6. So I'm going to put that point right here and the image point, which is right there. I'm going to go ahead and find out what f of 1 is. And that is 2 times 1 plus 1 squared minus 8, which is 2 times 2 squared minus 8, which is 8 minus 8, which equals 0. So that's right here. And the symmetric point, which is right here. So, didn't quite make it there. Looks kind of like that. There we go. All right, now what are my zeros? Well, that would be where it equals the x-axis, and these happen to go really nicely. They were really nice zeros, so I'm going to go ahead and write that down. My zeros are, my solutions are, or my x-intercepts are at 1, 0 and at -3, 0. And I would write this as x equals 1 or -3. These are my solutions. these are my root. These are my points. Okay. So now go to your warm-up and complete problem number 1. It requires you to graph in order to find solutions. A root is an x-intercept. And what I mean by that is when the function equals 0. Okay, so if you set f of x equals 0, that is what the root is, whatever x equals to make this true. For the past few classes, we have found roots of graphs by factoring. Okay, but what happens when we can't factor the equation? So here we're going to factor solve by factoring. Okay, so first I've got to make this equal to 0, so 2x squared minus 3x plus 1 equals 0. This is an AC method problem, so 2 times 1 is 2. That's 1 and 2. Bigger one's negative, smaller one's the same sign. So we have 2x squared minus x minus 2x plus 1 equals 0. Out of the first two, I can take out an x, and I'm left with 2x minus 1. And the second two, I can take out a negative 1, and I'm left with 2x minus 1 equals 0. So I have two factors, x minus 1 and 2x minus 1 equals 0. So now I have to find out what, using the multiplicative property of 0, what happens here. If they multiply to give me 0, one of them has to be 0. So I'm going to set x minus 1 equal to 0, and I'm going to set 2x minus 1 equal to 0. And here I'm going to add 1 to both sides, so x equals 1. I'm going to add 1 to both sides, so 2x equals 1, and I'm going to divide both sides by 2, and I get x equals 1/2. So my solutions are 1 and 1/2. X equals 1 and x equals 1/2. All right, let's try another one. This one is already in baby form. This is a baby method problem. I'm going to factor 5, 1 and 5. That's it. And these bigger ones negative, smaller ones positive, and they don't add to negative 2. So wait, we can't factor this. Okay? But if I know this thing has a y-intercept of negative 5. Okay? And I know it's going to go up. So eventually it should hit the x-axis since a is positive. But when does that happen? I can't find that. Okay, well that's where the next step comes in. So go to question number 2 on your warm-up and do the one with solve by factoring. Okay, the square root property. This is what the square root property says. If x squared equals a, then x equals the positive square root of a, or x equals the negative square root of a. Well, why? Well, for example, if x squared equals 25, say, then I would normally move this over and get x squared minus 25 equals 0. And then I would factor this because it's a difference of two squares. So this is x minus 5 and x plus 5 equals 0. So x minus 5 equals 0 and x plus 5 equals 0. So x equals 5 or x equals negative 5. But notice 5 is the square root of 25. And it's positive here and negative here. So that's what that means right here. Well, we can use the square root property to solve equations. So here's some examples. This one, I've got something squared equals a number. So I'm going to take the square root of both sides. X equals plus or minus the square root of 9. The square root of 9 is 3, so that's x equals plus or minus 3. Okay, so positive 3, negative 3 are my answers. This one looks a little more complicated, but I need that something squared equals a number. So 3x squared equals 54. I just added 54 to both sides. Now I'm going to divide by 3. So x squared equals, that's 1, it's 24, is 8. So I've got x squared equals 18. I'm going to square root both sides. And that gives me x equals plus or minus the square root of 18. Now I can simplify this square root by factoring it and finding what is inside it that is a twin. Okay, so this is 9 or a perfect square. 9 is 3 and 3, so I have two sets of 3's, they can come out. So x equals plus or minus 3 square root of 2. And there we go. Well, we can solve more complicated problems by using the square root property as well. So here we go. We're going to solve this. Notice I have something squared equals 2. So the first step is to square root both sides. So that gives me 3x plus 1 squared equals 2. I'm going to square root both sides. Okay, when you square root something squared, what you end up with is this stuff inside. And that equals plus or minus the square root of 2. Well, now I have to go ahead and get x by itself. So I'm going to do just that. I'm going to subtract 1 from both sides. Okay, so this gives me 3x equals negative 1 plus or minus the square root of 2. I can't do anything with that square root of 2 because they're not common terms. I can't add a square root and a 1. Okay, and then I'm going to divide both sides by 3. So my answer is x equals negative 1 plus or minus the square root of 2 all over 3. Oops, there we go. And that's my solution. Now there are two answers here. There's the positive one, which is negative 1 plus the square root of 2 over 3, and the negative 1, negative 1 minus the square root of 2 over 3. Okay, so there's two solutions, and I wanted to show you that from this little symbol here that there are two solutions. Alright, let's look at this one. Take the square root of both sides. I get x minus 4 equals plus or minus the square root of 5. Add 4 to both sides, so x equals 4 plus or minus the square root of 5. And I'm done. Well, here it is, folks. Time to work on problem 3. Last class, we wrote the quadratic functions in vertex form. That's what we'll be doing today. So, with a little twist. Alright, so let's try it, and I want you to go ahead and factor it once you've found the complete the square. Go ahead, pause the video, and try these on your own. Okay, hopefully you pause the video. So this one you get 4, and that factors into x plus 2 squared. This one you need to put in a 9, and that gives you x plus 3 squared. This one you need a 36, and that's x plus 6 squared. This one you need 100, and that's x plus 10 squared. This one is a little trickier because you have to divide 5 by 2, and that doesn't simplify, so you square it, and that's 25 over 4, which equals x plus 5 halves squared. And this one right here, the 2/3 divided by 2 is 1/3, and then I'm going to square it. So that's 1/9. So that gives me x plus 1/3 squared. Now, if I had a minus here, then this would just change the middle term here, okay? So that's where the minus comes in. Well, now we can apply this skill to a quadratic equation. First, set f of x equal to 0. If there is an a, divide everything by a. Then write the equation in the form x squared plus bx plus blank equals c plus blank. Then complete the square and add it to both sides of the equation. Then factor the perfect square trinomial and then solve using the square root property. Alright, let's try this. First, set f of x equal to 0. So we have 0 equals 2x squared plus 4x minus 5. Then divide everything by the a value. So here I'm going to divide everything by 2. Well, 0 divided by 2 is 0. 2x divided by 2 is x squared plus 2x minus 5 halves. So now I have to move or add 5 halves to both sides. So plus 5 over 2 plus 5 over 2. That gives me 5 halves equal plus blank. Sorry. equals x squared plus 2x plus blank. Now I have to complete the square. Well, you probably have already gotten there. You probably said, oh, add 1 to both sides. So this right here factors into x plus 1 squared. And that equals, this number here is 5 plus 2 over 5 halves plus 2 halves, which is 7 over 2. Now all I have to do is use the square root property. So you should have more space. I'm just going to come up here. We have x plus 1 squared equals 7 halves. Take the square root of both sides, and that gives me x plus 1 equals plus or minus the square root of 7 over 2, which, as I should know, this is plus or minus the square root of 7 over the square root of 2, and that's x plus 1. Okay. Well, I'm not allowed to have square roots in the denominator, so I'm going to multiply by the square root. So I'm going to multiply by the top, the square root on the top, and the square root on the bottom. So x plus 1 equals plus or minus the square root of 14 over 2. And that can't be simplified. And so I'm going to subtract 2 from both sides and get x equals negative 1 plus or minus the square root of 14 over 2. And in order to get this one to be in the same fraction, I'm going to go ahead and multiply this by 2 over 2. You can get negative 2 plus or minus the square root of 14 over 2. And that's as far as we can get it. Okay? So here's another one. First, set f of x equal to 0, so 0 equals x squared plus 4x minus 3. Second, there's no a, so just move the 3 to the other side, so add 3 to both sides. So 3 plus blank equals x squared plus 4x plus blank. I need a 4 here, so I'm going to add 4 here. And this is x plus 2 squared equals 7. Square root both sides, so this gives me x plus 2 equals the square root of 7, plus or minus. Subtract 2. X equals negative 2 plus or minus the square root of 7. And there we go. Okay. Alright, and here's another one. First, set f of x equal to 0. Second, divide everything by 3. That's the a value, so that's divide by 3, divide by 3, divide by 3, divide by 3. So that gives us 0 equals x squared plus 2x minus 2/3. Now move the 2/3 to the other side. So we have 2/3 plus blank equals x squared plus 2x plus blank. This one, to complete the square, I need a 1. I'm going to add that to both sides. 2/3 plus 3/3 is 5/3 equals x plus 1 squared. So square root both sides. So we have x plus 1 equals plus or minus the square root of 5 over 3, which that is x plus 1 equals the square root of 5 over the square root of 3, plus or minus, which equals x plus 1. I'm going to multiply the top and the bottom by the square root of 3 to get rid of that square root of 3 on the bottom. So that's plus or minus the square root of 15 over 3. Now I'm going to subtract 1 from both sides, so x equals negative 1 plus or minus the square root of 15 over 3. And now, common denominator, x equals negative 3 plus or minus the square root of 15 over 3. Ick. That's how it goes. And now it's your turn. Number 4, please. Oh yes. You can see him scariness. Ooh, bloody eyes would be cool. Alright. Well, what do I do next? Well, go to Edmodo and answer the following questions. What is a root? What are we doing this for? Just give me what a root is. If you have a question, please ask me. And bring your notes and cool down warm up with you to class. Okay. See you later. What I'll do is I'm going to make a short video on how to rationalize a denominator to help you with those square roots. If that's if you have issues with that. Okay, bye.